Hello, one and all. I am Varun Chowdary from VVIT CSE D, and I am here to explain you about recursive functions. Recursive functions are the functions which act as a loop in the program. Recursive functions is a function which call by itself. And now for the example for the recursive function, let's take an example for a loop construct of while loop. Here, for finding the factorial of a number, here we are defining a function called factorial and taking I is equal to 0, and this is basic program with the while loop. Next, alternatively, we can use recursive functions in this. Let's take this example. Here, this is the recursive step in the function. Let me explain you in detail. Recursion involves two steps. First step is keep on reducing the size of problems till we reach the end of a point where solution is known. Let's find the factorial of 5 using recursion. Factorial of 5 is equal to 5 into factorial of 4. 5 into 4 into factorial of 3. Thus it reduces to factorial of 0. We all know that factorial of 0. Now factorial of 0 works as the base case. Now let's work on backward for this function. Now we can solve factorial of 1 as factorial of 1 equal to 1 into factorial of 0, which is absolutely 1. Similarly, factorial of 2 equal to 2 into factorial of 1, that equal to 2. Thus, factorial of 5 can be obtained by 5 into factorial of 4, that equal to 120. Next on defining this recursive function, it can be recursive function on factorial is defined as VF is factorial of n, which is the basic definition of function. And here this is the base case, which have to be terminated at when n double equal to 0, it will return 1 and function will end. Else return n star factorial of 1 minus 1. This is the recursive step which has to be continued till n minus 1 becomes 0. Next, another example for the recursion is, let's take the simpler version of multiplying a b time. Here the recursive step is a star b, that equal to a plus b times. And we reduce this to a plus and so on b minus 1 times. Here a plus a star b minus 1. This is the recursive reduction. And this can be, their base case is if b double equal to 1, return a. Else, this is the recursive step. Return of a plus multiply a into b minus 1. A plus multiply of a comma b minus 1. Here a is the first, which will return if b equal to 1. Then b minus 1 will return if the b minus 1 equal to 1, then the function can be terminated by returning a. And next, first, what are the advantages of recursive functions? On using the recursive function, the size of problem reduces at each step, and the nature of problems remains constant. There must be one terminating condition which we call as base case. On using recursive function, the usage of function becomes simpler and more intuitive. Intuitive means if we have any error in this program, we can easily identify the error. This recursion is close to mathematical specification. This recursion makes easy from programming point of view. And this is efficient commutation in point of view. And next example for recursion is GCD algorithm. GCD algorithm means in GCD of, if we pass GCD of A comma B, which have to be written B as its first argument and GCD mod of A comma B is its second argument, it has to be passed. If A mod B double equal to 0, then function has to be terminated. This can be written by using while loop as define GCD of A comma B comma R equal to A percentage B while of R not equal to 0. This is the terminating condition in while case, and taking A, getting the value of B in A and getting the value of B comma R and returning B will give us the recursive function in while case. On defining this with the help of recursion, because this is the base case here, A percentage B equal to 0 and it will return B. Else, it will return GCD of B comma A percentage B. This is the recursive step in the function. Yes, see. If of A percentage B double equal to 0, then it will return B to function calling. And this is the tracing of the GCD function. GCD of 6 comma 10, which on next step returns GCD of 10 comma 6, which on next step returns GCD of 6 comma 4, which on next step returns GCD of 4 comma 2, and next return 2, and it will return 2, 2, 2. Thus at last we get the answer 2 for the function. Next example for recursion is Fibonacci numbers. Fibonacci numbers means the initial condition if n equal to 1, it has to return 0. If n equal to 2, it has to return 1. And if n greater than 2, then Fibonacci of n equal to fib of n minus 1 plus fib of n minus 2. And if we use if loops in this creation of this Fibonacci sequence, we have to define a function called fib of n. And next if loop, if n double equal to 1, it has to return 0. If n double equal to 2, it has to return 1. Else, it has to return fib of n minus 1 and fib of n minus 2. This is the flowchart for the Fibonacci sequence. And we can get the power of the function by using recursive function. Let's take this example. Write a function power of n to computate n to power of x. Here power of x comma n equal to if n equal to 0, x as x for 0 equal to 1, it has to return 1. Otherwise, it has to return x star power of x comma n minus 1. And on using if loops in this, we get define power of x comma n, and if n double equal to 0, it has to return 1. Else, it has to return x star power of x comma n minus 1. And if we use recursion for this, we get efficient power function and faster the power, because it involves very easy steps and the length of the program is also decreased a lot. And next, for finding the efficient power function, we have to define a function called f power of x. If n double equal to 0, it has to return 1. Else, it has to return x comma y comma y. Next main example for the recursion is towers of Hanoi. In towers of Hanoi, we use 16 gold discs with different diameters, which has 3 poles, origin, parent, final. In towers of Hanoi, origin has the disc, and we have to use pair to transfer all discs to final. This problem can also be solved by recursion. Initial arrangement. All on original plane, largest at the bottom and next smallest above it. And in first step, we transfer the smaller disk and we transfer every disk into sphere, and finally we get all disks in the final plane. These are the algorithms for the recursive function. And next, print move of from and to. This is the returning of towers of Hanoi using recursive function. This is the program to return towers of Hanoi. Here we get print move of from and to. Print move from str of from. And next, print to and concatenate it with str of to. And towers of Hanoi, here it has 4 arguments n, fr, 2, space. If n double equal to 1, print move of from, 2. Else towers of n minus 1 from spare and 2. Towers 1, from 2 spare. Next towers n minus 1, spare 2 from. And thank you for giving this opportunity, as this is the end of this phase. Thanks everyone.